Hello, Math 152. If a of x equals integral from 0 to 3x, 1 over 1 plus t squared dt, then find part A of 1/3, and part B, a prime of root 3 over 3. So let's look at part A. Of course, we're using fundamental theorem of calculus. We are asked for part A to find a of 1/3. This means that a of 1/3 equals from 0 to 3 times 1/3, 1 over 1 plus t to the second dt. And so 3 times 1/3 is, of course, 1. Let me go ahead and go to the next page, and excuse me, a of 1/3 equals from 0 to 1, 1 over 1 plus t squared dt. So at first glance here, if you don't have so many hours of practice, you are going to be tempted to use a u substitution, something, let's say u equals 1 plus t squared. But soon you'll realize that nothing is going to cancel out, and this is not going anywhere. So what's helpful here is to remember that in Math 151, first part of calculus, we learned that d dx of tangent inverse of x equals 1 over 1 plus x squared. And you know that derivatives and antiderivatives are inverse of each other. So if d dx of tangent inverse of x equals 1 over 1 plus x squared, then the integral or antiderivative of 1 over 1 plus x squared must be tangent inverse of x. So using what we learned in Math 151, we are going to just go ahead and rewrite this as from 0 to 1, 1 over 1 plus t to the second dt. Let me write that as tangent inverse of t from 0 to 1. Okay, and that equals tangent inverse of 1 minus tangent inverse of 0. Okay. Remember that tangent inverse of 1 means I'm looking for an angle whose tangent is 1. And this right here, tangent inverse of 0, means I'm looking for a theta, or in this case t, for an angle whose tangent is 0. And remember, the restriction for tangent inverse was from negative pi over 2, negative pi over 2 not included, all the way to positive pi over 2. So anywhere in here except negative pi over 2 and pi over 2 itself, because tangent is undefined on negative pi over 2 and in positive pi over 2. So the domain for tangent inverse, and we write it in here, is from negative pi over 2, negative pi over 2 not included, to pi over 2. Okay, so where is between, if you think of this as unit circle, where in here, where is the angle that whose tangent is positive 1? Well, tangent is positive 1 only in pi over 4. So this part right here, the first part is just giving me pi over 4. minus. Where's the, where in here between negative pi over 2 and pi over 2, at what theta, in this case, what t, the tangent is 0? Well, tangent is sine over cosine. And I'm looking for the point where sine is 0, and that would be 0, sine of this point right here, 0. So that equals only pi over 4. So that's the answer to part A of this problem. The second part of the problem, let me go to the next page, is asking us, let's say part B is, what is a prime of root 3 over 3? So recall that we started as a function of x equals 0 to 3x from 1 over 1 plus t to the second dt. Using fundamental theorem of calculus, I can write, let me change color, that a prime of x equals, I'm going to go ahead and replace this t with the 3x. So I'm going to have 1 over 1 plus 3x to the second power, and using chain rule, multiply that by the derivative of 3x, in this case, 3. So a prime of x equals 1 over, or actually 1 times 3 gives me 3, 1 plus 9x to the second. All right. So now let's find out what is a prime of root 3 over 3. That equals 3 over 1 plus 9 root 3 over 3 to the second power. And that equals 3 over 1 plus 9 times root 3 over times root 3 is just 3. 9 squared is 9. And so I'm going to go ahead and cancel this with this. And my final answer is going to be 3 over 1 plus 3 is 4. Okay, email me if you have any questions. Thanks.